Hi, everyone. Thank you for joining us today for Now You See IME. This is part 4 of the Let's Make a Cloud App with .NET series. Before we start, I have a few quick things to go over. Please take a moment to read our code of conduct. We ask that you be kind and respectful to everyone, including our speakers. We want the reactors to be a place everyone feels welcome. Please ask your questions using the live YouTube or Twitch chat. In the chat, I'll also be sharing some links to the Reactor Meetup page and monthly newsletter if you're interested in checking out what else we have coming up. If you haven't already, please check in at aka.ms/reactor check-in with event ID 14753. By checking in, you'll receive links to the content that go along with today's session. We will be adding this to our Reactor YouTube page in 24 to 48 hours. And finally, towards the end, I will share a link to our Reactor survey. If you have a few minutes, we greatly appreciate your feedback. I am now going to pass it over to Sam.
Awesome. Hello, everybody. I am Sam Wronski. I am a regional cloud advocate here at Microsoft, focused on empowering people in the Bay Area to build awesome things with Microsoft technology. Today, or this month, we're building a cloud app using some of the new features in .NET 6, as well as experimenting with some live coding and Azure Functions and Service Bus. So this is sort of a co-learning stream where I am learning these features at the same time as you are potentially. And we're kind of walking through how I learned that, how I designed the app, and sort of the problem-solving process that I go through in that. So this entire project is about a 10-hour chunk that we've kind of carved out over a series of 5 days to build an app. And so as we're going through that, we're building different parts of that. The application is intended to provide different transformations of meshes. So in that case, we have this cube here. I'm going to just move that back. But if we enlarge that so everybody can see it, we have 3 current operations we can do. We can translate things in space, which is to move them around. We can rotate them, and we can scale them. We've implemented our own math library, put that under test, and then wrapped all of that in some Azure functions. So we can actually provide some arguments here and get a transformed mesh out of the results. So in this case, we were sending over a mesh with 0, 0 as the single point in the mesh. And then we were translating that, which means moving it in space, by x = 5 and y = 10. And so the result down here is x = 5 and y = 10. So we're actually moving our mesh around. So now what we need to do is actually dive a little bit deeper into this. At the end of yesterday, we were implementing Azure Functions and looking at how to do Service Bus queues-based Azure Functions. I've done a little bit of work off camera just to connect everything up, just to make sure it all syncs. So what I've done is the default was putting a connection inside of this trigger here and adding the connection string in your code. I have moved that out to the local settings under the Azure Web Jobs Service Bus label. You'll note that local settings.json is a ignored file. So if we look at the git ignore that's generated with Azure Functions, this is excluded from our GitHub, which means this file will not be checked in. So we will need to reconfigure this when we're actually doing this, but this gives you a way to define your local environment without having to publish that so that everybody can see it. It also avoids having duplicate configurations overriding people because you have different developers working on the project. So this is a way to kind of separate that out. So what we do is if we run this, we have 2 functions right now, and they should both run at the same time. And so we will get this function, which is going to start 2 things. And we'll get our function here, which publishes the function 1 at a specific API endpoint. That's sort of our test thing, just to prove that's working. That's the REST call that I was showing previously. And we have a service bus trigger that is registered for a service bus queue that we have already configured. So we set that up yesterday. And it's just going to Azure Service Bus, creating a new service bus, and then assigning a queue. For setup, I use a basic Azure Service Bus. And what that does is mean that you're charged based on operations, the number of times you read and write messages to that queue. And so that actually means that if we're not using this, we shouldn't be incurring cost. And that's sort of a nice thing for us for a development application. It means that our Azure functions incur cost only when we're sending things to them, when we're processing requests, and our queue does the same thing. So only during the workday when we're actually sending messages through this thing are we going to actually incur any cost. So let's actually just run this again. Let's change this to say 4 and 4 and hopefully get a different response. We don't have tests over this. That's what we're going to be kind of building into today. Today is sort of the transition between implementing our application and adding the infrastructure. The next 2 days that we've kind of set aside for this project after today are focused largely on our infrastructure and telemetry data. So we can actually prepare this thing for launch and make sure that it's actually working. So we hit a breakpoint here, so let's jump over that. Because we have breakpoints because we were testing some things. And so our new thing is translated to position 9 and 14. So we've kind of moved our points around in space. So that is our entire trigger system. Now we need to actually work with the service bus to actually get that to work. Right now it doesn't. So we should be pulling messages off of the queue using our service bus declaration. And so this should be attached to our service bus queue. I've also added a service account behind the scenes, a storage account rather, and that stores information about triggers and things that for Azure functions. In this case, we need to actually start publishing things to our queue. So what I'm going to do is just whip up a really quick application that publishes things to this queue. So we can actually start testing this. I think that's the best way to do it. There's a lot of different ways you can do this. For me, I just want something really quick and scrappy that is not going to be published. It's just a developer tool for us to kind of work with to get messages into this queue, hopefully pretty quickly. And then we can kind of work from there. So I'm going to make this up as I go, just like this entire project. I don't have a plan. I don't have a script. We're focusing a lot on how do I solve problems? How do I implement our architecture? How do I actually get this thing to work? So that's what we're going to focus on today. Is kind of pulling all the pieces together and getting something to the point where we're ready to actually validate it in our environment. That's sort of the end point. So we're going to create a console app here. There's actually a demo of how to do this, so we're just going to call it our Matrix Mesh Service Bus Tester. We'll probably potentially come back to this. I don't know how long this is going to live. I don't know entirely what I think about this, but we're going to kind of play around with this tool and make it a little bit better. I pulled up something, walk through creating and using. I lost the one thing that I had pulled up. Cool. Planning, it's going great. So under this publish and subscribe for messages doc, there is a different set of things for how to use different APIs inside of the application. So these are different ways you can interface with Service Bus. And so we're going to kind of be creating that. The role that we created previously is only for consuming messages. So it can't actually publish new messages back onto the queue. That's just not what it's for. So we're going to need to kind of re-implement all of this. The code's already here. So we're just going to largely copy and paste this and then see what we get. And then go from there. We do not need all of this. So we're using .NET 6. How do I handle latency and order of execution? Messages are not ordered on the bus. I believe Service Bus can give you messages in order. I'm not entirely sure. It's a tool that I'm still learning, but I believe that's one of the advantages. Let's just double check that. For this case, we don't actually need things to be in order, so it should be fine. We're just trying to process things and get them into some process thing. So that's sort of what we're looking at. But if you want to process things in order, it should support that. I'm not sure about the best way to improve the execution of that. We're kind of using this as an abstraction layer between the different part components in our system. So in this case, our application sits in between two queues. Now let's just pull up. I have a diagram for this. Let's just pull this up. So this is sort of the really quick architecture that I put together. Ignore the fact that it's kind of rough. It's just a generated tool. But matrix transformation request queue and the result queue are the two ends there. So that's what we're using Service Bus for. Is there's a queue for requests of transformations and a queue for resulting transformations, the end results. And then our services sit in between. The advantage of doing this is that you eliminate some of the need for your service to keep up with everything upstream and downstream. You can actually scale different components in your system to different things depending on the need of your application. So that's why I've kind of gone with this. I found it useful, especially if you have things that are doing really complicated processing systems that might take a long time, and something that's going to just do what we're doing, which is literally just add numbers and then pass it on. Those are very different latency requirements. They're going to happen at very different speeds. And so having them separated by something that can kind of regulate that and sort of remove the dependency of our services needing to rely on the scale and reliability of our downstream and upstream services saves us a little bit of headache. It does introduce a few complexities with queues, but I think that's a nice trade-off. And in this case, Azure Functions should take care of a lot of the complexity for us. So that's why we went with that. There's definitely, with every software decision, there's always different choices that you can make. You can go in a whole bunch of different directions. We could have done this in Kubernetes. We could have done this with service apps. There's just different options for this. We probably could have done this with a console app, honestly, and it would still work. The difference is just sort of, I guess, your end infrastructure and how you're going to maintain and support it. So whatever makes sense to you, it could be a good option to go with. So anyway, that's a detour. What were we doing? We were talking about service apps. We were going to grab this. So we're using .NET 6. We do not need the full thing. Then what we can do is actually just pull this entire thing in. Because we're using top level functions, I believe that's the name of them, we can just paste this code here and it should work. We do not have any of the Service Bus stuff, and I don't think it's going to find it for us. Oh, there it is. Install package, the Azure service thing. And we're just going to install the latest version. So there we go. That should give us Azure Service Bus. We can just configure a few of these so we actually have all of this stuff defined. Number of messages is just going to be 1, so we can eliminate this for loop. And really all this test app is intended to do is just publish a message to the queue. So that's what this try add message is doing. It establishes a connection and then publishes. This is publishing to topics, which we do not have. So we'll need to change that. There are two different distinctions with Service Bus. There are topics and queues. My understanding, again, still learning this, but my understanding is one of the big differences is whether you want multiple consumers versus just one. A queue is just going to have one consumer. So connection string is going to be coming from an environment variable, I believe is the best way to do this. Again, do not put credentials in your code. The best way I found to do this is with an environment variable. You can also use things like key vault to store that. For development, we're just going to use an environment variable, and that will give us a way to interact with this. So let's put that together. And then our topic name, is, I believe we can do a queue or a topic. So we're just going to call this the queue name just to make it align with what we're trying to do. And this queue name is actually already defined for us. So we can actually go and pull the name of that queue with the matrix transformation requests and plug it in there. Theoretically, we could pull that in as a separate environment variable. It doesn't need to be, though. Again, this is intended as a very scrappy way of doing this. We're going to be including a bunch of different things. We're probably going to actually depend on that Azure Functions library just to get this to work. Just as sort of a way of expediency and getting this tool just to get us something. So message is too large to fit in the batch. And I'm just removing the things that refer to the number of messages. We're just going to publish one message and then just update this console application every time we want to publish a new one. So we can just rerun this program to publish a new message into our queue. We could also have it so you could provide things from the console or a file. I'm just not going to. The goal here is just to get this going as fast as possible. So that's what I'm focusing on. A batch of messages has been published. I don't even know. Messages to a topic are for pub sub style publication with 1+ subscriber apps. Queues are for single subscriber. Those microservices, there could be multiple instances. In this case, it's called competing consumer pattern. Yes, I think in our use case, it made sense to use a queue. We're also sort of iterating on this and trying to get this done. Again, we're trying to build an entire app in 10 hours, which counting detours and stuff with streaming is less than an engineering day. So there's definitely intentional technical debt and things that decisions we're making that may not be ideal. Part of the goal of this is to kind of provide a more realistic look at what this process looks like, and also give us a way to showcase how we can actually address some of those things later on. So some of the technical debt and architectural design decisions that we've made that maybe don't align with what we're trying to do can actually be useful, because you're going to run into that eventually in your own applications. Probably in something more complicated than what we're building, but they still come up. So anyway, that's what we're looking at. Service bus message. And then let's just add that. So our message is just going to be a string. We can just provide that string here. I don't know what the best way to do this is, so let's just put a string. In this case, I'm actually literally just going to plug that in. We can use what is the thing from multi-line? I think it's that. So at should give us a multi-line string, if I'm remembering correctly. So we'll actually just get a multi-line thing. You can see we're not getting a syntax error because even though I don't have a syntax error, or I don't have a semicolon, and I'm not closing my quotes. So we're still getting all of this stuff working. Then what we can do is just grab our message and paste it in. And we're doing this. I don't know. This might be an issue because we actually need quotes here. I'm not very familiar with this @ symbol. I use it typically just for really quick paragraphs. So this may not actually work great for us. We could use single quotes, and I think that would get rid of the issue. But that might not be the best. Instead, maybe we just pull from a file. Could you connect to the service bus using an identity instead of needing a secret connection string? Maybe. I'm not entirely sure. In the documentation that I've read, it's used a connection string, and so that's what I'm using. There might be an opportunity for us to provide a better identity solution here. So I might explore that. Right now, we do only have a limited amount of time here, and so I'm trying to kind of. Admittedly, there are corners that are being cut because that's just the nature of this whole thing. But that's sort of how this is working. We're trying to kind of build an MVP that's proving out this application that we can kind of ship and provide the general operations for, and then we can build more onto it later. Read all text. And let's just read all the text from message.txt. And I'll figure out where to put that later. And then we have our message, which is just going to be publishing a message. And then we have our message, send message async. That's just sending the message and then pressing any key to continue. We do dispose of the sender, so we shouldn't keep anything open. Get environment variable, we actually need a name for that. So let's grab our environment variable, which is our connection string. Service bus queue publisher. I don't know the best name for this, so we're figuring that out. But we get a service bus queue publisher. Let's actually set that up so we can actually add an environment variable here. I'm still kind of figuring out some of the Visual Studio things. I'm used to Visual Studio Code, so we're kind of exploring this a little bit. But there should be a way to add environment variables. So if we go to edit project file, that's not right. If we look at our project file, which what? Okay, pressing the wrong thing. That's cool. Manage user secrets. I don't think that's what we want. We want to actually look at the project, which I have blanked on how to do for whatever reason while live streaming. That's cool. So that's fun. Properties. There we go. Neat. Environment variables. And so you can actually define custom launch variables here, just setting envs. And so we're going to add one here that has our queue publisher connection string for us. And so from there, we're actually going to need to create one. Our current service bus our service bus role is strictly for reading. It's just there to read messages off of the queue. So we actually need a new one that can actually publish these. So that's what we're going to be creating here. Let's just go to the portal. There we go. And create a new role to do that. And so we're just going to make one that can send new things. So this is going to be our test message sender. And create that quickly for us. And this should give us the ability to actually send messages without having to be able to manage or listen to what those messages are. This specific role is just for publishing those things, so we can actually kind of limit that. And then we can grab our connection string and set that in Visual Studio. Again, I'm going to re-roll these credentials after creating all of these things, so this stuff should go away after we've done this. But that's that. Do not publish your credentials to source control. So we'll need to double check that doesn't end up in source control. That's something to make sure and double check because that's not fun. So let's do that. That should give us our connection string. And then let's add a file here. For me, the easiest way to do this is from Visual Studio Code. I guess I'm mixing and matching because why not? So let's just add that, and we call it message.txt. And then we can grab our message and just paste it here. And so this gives us all of our messages that we're actually going to be sending. And we should be able to actually publish this to our queue and see a result. And then let's see if this works. So we have our connection string. We have the queue name and all of this. I think it should just work. We'll see. Again, I'm learning this as we go. So we're figuring it all out. but this should be good enough for us to actually get something published to our queue. If this runs, no, cannot be parsed, or contains no well-known keys. Okay, not sure what that means. So let's actually figure out what that's saying. But for me, I'm just going to go and search this because I don't actually know what this means. So connection string from Azure Service Bus. Go to Stack Overflow because there's always good answers there. Should be specified. What's on the end here? Okay. It looks like everything's good. We're not using storage queues, so that should be fine. Primary connection string. If anybody knows, let me know. Otherwise, we'll continue debugging this. One of the things I'm trying to do is avoid any internal resources that I might have access to, just to kind of debug this and figure out what the learning process of some of these tools are. Because that gives us a good idea of what some of the things people are going to run into are. Because I don't really know what's going on here. That seems correct. Shared access key with the name. That's not right. There we go. And this has our shared access key. Okay, not sure. Could be the environment variable character escape issue. That could be true. Let me double check. I think we're getting the right thing. How would that show up as? The slashes? So there are forward slashes in this. Is that the right name for them? From bottom left to top right. I always get them mixed up. There are those. I think that should be fine. I'm opening the wrong browser. You are right that if it's a character escape issue, it would show up wrong in the browser. So let's double check and just make sure that everything is good. Or what we can do, we'll try this. I think this is the better way to do this. There are potentially cheats that we could try to get around this. Endpoint / is that correct? I don't know if that is. I think we have extra characters in there, which doesn't seem great. So let's debug this. This doesn't look right actually. So like there's endpoint / equals, which I think should just look like that. Believe, is there a way for us to commas and equal signs are pinned within a variable can be escaped using a /. So if we do a / that should escape those. But I think we're actually getting the errors here. So if I rerun this, we'll get the error again. And if I look at this, there is no / there, but there is at the very beginning of our endpoint. So you can see here, there's a / at the very beginning. So what we can do just to get past this, so we're not stuck here, is skip the environment variable and do this. You shouldn't do this. But if for as a debugging tool, I have found this useful. The downside is you need to be very careful when doing this. Want to be very, very, very clear here. Let's actually go back and grab it. But what I'm going to do is literally paste this into the source code and then immediately remove it, just to make sure what I'm seeing is actually working. All right, connection string, cool. So let's remove that and go here and paste this in. And what this is going to tell me is if this connection is working and if it's a formatting issue or if it's something else. Very important that I remove this immediately because we're putting things directly in our string. We're putting secret information in our code, which is not a good idea. So that's what we're doing here. This gives us a way to validate this and prove that this is the issue that we're seeing, and actually get past that error. Can't find the file, that's fine. It's looking in our binary folder. That's cool. We can fix that. But this tells me that it is a formatting issue with this connection string. So the connection string worked if we pasted this in, and now we can immediately remove this. Again, be careful when doing this because it will tell you different things. And it becomes very easy to actually put your code in your, or you put your secrets into your code, which you just don't want to do. I did that to avoid any issues with formatting and kind of detect those. All right, so I think we can just remove those double slashes there. I don't think those needed to be there. And then we can paste this or save that and run this again. That's not going to work. That's the wrong file. If you're unfamiliar with Visual Studio, you can actually set the default start thing by just clicking set as startup project down here. And that will change it for you, or you can change it up here. Both of those work. I've found that I just do the debugger, and there's a bunch of hotkeys to do this as well. Connection string still couldn't be parsed. What's going on? Weird. Okay. I need to take a closer look at this because I'm getting confused. This is not doing exactly what I thought it would do. We have some slashes, endpoint equals stuff. Okay, so we only have one slash here. That needs to be fixed. That's what's going on. So we can get rid of that, add our space there. Didn't really allocate a bunch of time for this. So I'm a little bit stuck, but that's cool. We're going to add 2 more slashes here just to make sure. I don't think it escaped those. And so if we run this now, we run into the issue where our message isn't in our bin folder, which is fine. We can actually look somewhere else for this. So we have our message.txt. I believe we can just copy, flag this to copy to the build directory. So what I did there is click on this and copy to output directory, which should put it in the output build directory for us. And so it should now be found. And so we publish our message. We should now be able to see that out in Service Bus. So if we open this and look at our overview, we can see a bunch of different requests. And we should see an incoming message come in eventually. I believe this can be delayed a bit, so we're just going to let that sit. But what we should be able to do is actually run our queue and see if we get any results. We should see a message come through there. And so what we're expecting when that comes through is just we're going to write out some text. So we just log some information that a message was processed. So if we set this to start new instance, this will run our function. And so we have those. And where are we? It looks like we're actually already in our code. So we're actually already pulling in the message here. We're executing the mess transformation queue function. So we found a message and pulled that down. And now we should be in doing translation stuff. So I'm going to remove that breakpoint and just let it continue. And so now we processed a message with a new point equal to 9 and 14, which is the same thing we got with our process thing. The JSON is condensed, so it's shrunk down for us. But our service bus function now processes these messages. So as we publish more of them, we should just see them work. I don't know if there's a quick way for us to do this. So what's the best way to do that? I guess we can just stop that. But anyway, we now have a way to send new messages. All we have to do is update this message.txt. And that gives us a new message for us to process and work with. We can make it more complicated than this basic one and then go from there. But that at least does our message processing. That gets us to the point where everything is done. We just need to publish it back onto the queue. I'm going to leave that for now. What I'd like to focus on next is testing this. We have tests over our math library that's actually doing the math for this, that handles vectors and the matrix stuff. But we don't have anything over this function. So that's what I'd like to add next, just so we have some more tests. And then we can update our GitHub Actions to actually validate a lot of this stuff for us. There's also GitHub Actions to test and publish your Azure functions directly to Azure for you. So hopefully we'll get to that as well. So let's just add another new project here. And we should just be able to find XUnit. The previous XUnit project was actually created from the console using .NET New XUnit. So this one might be configured slightly differently just because we're creating them in two different places. It should be fine. And if not, we can reconcile those differences. So this is going to be our matrix mesh functions tests. Capitalize that. There we go. And we'll target .NET 6. The entire project is targeting .NET 6. We should be able to just use top level or file scope namespaces and remove all of that. And we get the same, it looks like, project template, which is cool. So we have our matrix math functions. Let's actually add a reference here. So add a project reference to our functions. And let's also include math. So we can actually access some of the math that it's supposed to be doing. We may or may not need to actually publish some of that, but these are going to be more complicated tests because of where things are located. These are also, the code for these functions was written prior to testing, which means it may not be perfectly testable as written. We may need to update that to actually make tests a little bit easier to write for this. So that may be a consideration we actually need to make as well. So let's start somewhere, and then we'll figure out where to go next. So I think maybe the best thing to start with are these transformation functions. What these are doing is grabbing a specific mesh and running the arguments against that. So actually making sure that things are working. What we should test is that it actually grabs the correct argument. So actually make sure that the argument exists and uses that. And then other than that, pulls a few other things. These two need to be updated as well. So we aren't testing if they contain the key, we're just accessing the key. Our test should show that that's a bad idea. So we should run into some errors there. So let's do that. Let's do a transformation controller test and rename our class. And we're going to have a translate. Let's actually start with rotation because that's broken. And that will give us a working point to actually improve this. So rotate, rotate transformation test. I guess we can start there. So the transformation controller has a bunch of different classes in it. So this actually isn't a transformation controller class. It's the rotate function. And so if we go here and create a new rotate function var, function is equal to the new rotate function. Like this. So this creates our new rotation for us. And then what we can actually do is actually run our tests. So again, when I'm writing tests, I like to focus on given and then when something happens, and then the expect. So these are sort of the verbs that I kind of think of when I'm phrasing my tests. And it kind of helps isolate them into that three separate things that are going to happen. We're going to define the current state of our application, perform some function on that state, and then expect the state to be in a new state. That's sort of how this works. You can phrase it in different ways that make sense to your application, but this is just a pattern that I found works really well and becomes pretty readable as you start scaling up tests. So let's try this. Let's do a function dot transform. So the transform function is the interface that these implement. So we need a mesh and we need some arguments here. Transformation test, rotate, transform fails when rotation not provided. The names of these tests might get a little long here. That's fine. I find that it's kind of helpful because it tells the story of what this test is. Again, they're intended to be helpful for you. So if that isn't helpful for whatever you're testing or whatever you're writing, go with a different naming style. People do it different ways. And so you don't have to duplicate what I'm doing. Transform here, we need the mesh. So we're just going to provide the mesh and the arguments. So now we need to actually define those. So let's create a mesh, which is a new mesh here. So that isn't defined yet, so we'll grab that. And this needs, I believe, a series of points. So a new list of vector2s. I'm just going to use another list constructor here. And we can actually, we don't even need to do this. We should just be able to provide shapes dot centered quad. And we have some helper functions that have shapes predefined for us. We can use one of those as our rotation. What we're looking for is that this is going to error out in some way. So function.transform mesh, we have the arguments. Var arguments is a new dictionary with strings and some other objects on the other side. So we're going to provide a float here. And then there's going to be two real tests that we kind of want to do here. So this function or this test will be duplicated again. These can be harder to abstract away using a theory, just because there's some more complicated setup for them. But we should be able to do that as well. In this case, we're going to test if something exists that is not a rotation. So we're going to call this, say, X. And instead, we're going to provide some float, so some valid float here. But it will not work for our use case because it is the wrong name. And so, not be found. Let's actually import that. Then we transform this, we get our result. Plug in our arguments. This needs to be of objects. Here we go. And then we expect this to have thrown some error. So in this case, I believe there's a way to test this. We might not even need an expect. It's just going to throw. But I think it's assert that throws of some exception. Verifies that the exact exception is thrown. And we want something. I don't actually know the name of the exception that gets thrown when a dictionary cannot find its type. So let's go and look that up. Dictionary C#. And we're just going to go and quickly search for what the name of the exception is for this. So we actually know which one to expect to catch. And where methods. And we want the get type or contains key, contains value, get item. There we go. So this should give us a way to get our information, and we'll get a argument exception. I don't think this is what we want. Dictionary stuff. Values, keys, removes, copy to keys. Okay, this should be fine. So what I think we want is an argument exception that's going to say this doesn't exist. I could be wrong here, and we'll key not found. That's a good call. That is correct. Anyway, my brain gets weird when you do streams. So assert that this code right here is going to throw something. And I don't even know if we need to explicitly require a type. This might just work without that, or we might need to do key not found. There we go. Cool. And then I can pull this out. And so when, in this case, it actually kind of combines the two different things. We need a semicolon here, so it actually works. And then I can run this test. And so hopefully this passes and we see a failure, or we see an exception get thrown. One of the things that is useful with tests is to always make sure that they actually fail. It's really good if all your tests are green. That's great. But if all your tests are green because they don't actually test the things that you think they're supposed to test, that's less good. That becomes less useful. And that can actually be really hard to identify sometimes. And so figuring out a way to prove that things actually will fail. So if I give this something that won't throw an exception, like rotation, I believe that's what it expects. Expects rotation, so that should be good. In this case, we expect the rotation, so it should pass and should work, but we're expecting a failure. So this test should now fail. If that's true, and we actually have a little bit of confidence in this test that it's doing something useful for us, and it's actually providing some amount of error. In this case, we do get a failure. No exception was thrown. And we should also, if I was using a different exception, like argument exception, is that a thing? That might be a Java thing. Anyway, exception, key not found. That's the only exception suggesting. Okay, fine. Go back to that, key not found. There we go. So we get our key not found exception, and this actually gives us an error. So we now have a test that is a little bit useful for us. We also want one that's going to prove that this actually works. So I'm going to actually write two more. One is going to be for an empty dictionary. So in this case, we should get the same error. But in this case, we're testing an empty dictionary. This is just one of those edge cases that I feel like you probably want a test for. There are ways you might be able to condense some of these, but this fails when arguments are empty. And so we're going to test that. This one, these are the same name. So this, we actually want to have the name of rotation. Rotate transform fails when this doesn't happen. Rotate transform succeeds when rotation provided. And so what we're testing here, we've actually already have tests over these functions that are doing this math. So our rotation is already under test. So this line is not the thing that we really care that much about. What we're looking for is this rotation is provided into our function. So that's sort of what I'm going to try to test here, not to validate that maybe the rotation is correct. That might be the best way to do this. One of the downsides of that is now we have rotation tested in two different places. And maybe it doesn't make sense with rotation, but let's say we changed it. So instead of rotating clockwise, it rotated things counterclockwise. In that case, we might get different results because of the transformation we're doing here. And so that can be a little bit confusing if you have the tests in two different places. It can be hard to maintain that. And it can provide mixed feedback on what's actually happening. And so this is something that I found useful, is just to kind of figure out what you actually need to test and focus your tests on that. So let's look at our transformation controller test. We're validating that our rotation works. And so this doesn't actually need to test for an exception. If we get an exception here now, it should just fail. So if we run into any errors here, it should just throw an exception, and that will fail our test because of the exception. So it should just work there. But what we can do is do like math.py. We need to import that library. And this should be mathf, I believe. I think they're the same, but I've been using mathf throughout the rest of this. So we're going to kind of keep this as consistent as possible. So we end up with mathf pi as our rotation. That should rotate 180 degrees. And that hopefully gives us a transformation with our result. And then we expect some result here. That should be the next thing. Where is it? Our mesh test. Here we go. So we have a scale, translation, and rotation. We're going to look a lot at these to confirm that they're actually doing the same thing. In this case, we're actually rotating a quad by a specific amount. We can basically copy this. I just talked about this. Depending on what we need to test, copying certain things can make sense or it cannot make sense. In this case, I'm going to for this test, and we might pull it out later, depending on what makes sense. One of the downsides of this is if it works, there's not that much incentive to go back and fix it. And so that can be something to keep in mind, is if you are writing something like this, and maybe there's another way to do it, then you can do that. One thing we could check, I'm also learning XUnit. I've done .NET for like 10 years, but the past 2 to 3 years has been focused on a lot of like infrastructure and tooling stuff in other languages. And so I'm still picking up some of the same things and trying to remember a lot of the things that I used to know. But there should be way to do mocks in XUnit. I don't know. We might need a different framework with like mock or something. But maybe there's an option here to run a mocking framework. What that will give you the option of doing is saying, was this function called? And that's really what we want to validate. We do not want to validate, because we have that other thing validating the results of a mesh transformation. We don't need to do the entire call stack and validate the entire call stack. The mesh transformation is already handled for us. What we're really trying to do is validate that rotate on our mesh is invoked one time with a specific argument. And that could be something that mocks can help with. We might leave that a bit just so we can kind of move things along. That might be some technical debt that we want to address later. So anyway, we'll move on from here. That gives us 3 tests. These should all pass, I think. So I've screwed something up, but hopefully not. And so now, hopefully, we get some failing tests. Oh no, this should be quad. So the centered quad is centered at 0. So the middle of the quad is at 0. In the quad itself, it is 0 to 1 as our points. And that's what we're looking for here. So that would explain why that didn't work. Just the wrong argument. And so all of that is now passing. Good. So we now have at least some information that this is passing. We may want to push some of this off. and I can do some more of this offline. Testing can take time. And a lot of times testing takes longer than actually implementing the code because you need to actually consider all the use cases for that code. So trying to kind of think critically about what can go wrong and what you want to validate. Your tests sort of describe the behavior of your application. And that can be more verbose than the code that is actually performing the operation. In this case, we wrote like 40 lines of test code for 2 lines of actual code, which is a lot as far as differences go. But that entire scale can get crazy. So that's that. What else do we want to look at? These are all of our serialization things. So these are just serialization data points. And the other thing that I think we should look at is putting our functions under test. This is going to be a little bit harder. I'm going to focus specifically on the queue because that's the actual thing that is our main app. The HTTP REST request function is there for testing mostly. So let's do that. Let's add a new item here. That is going to test this. So we have our matrix function tests. Let's call this our mesh transformation queue function test. And so what this is going to do, again, going to do top level namespaces or file level namespaces, file scope namespaces. Got there in the end. So what this is going to do is actually test that function class. And I imagine what we're going to end up doing is pulling a lot out of this function. It should just work. We should just be able to test against this function without having to do too much. We may need to provide a mocked logger or something to log just so that works. But also, we've put everything into one function more or less. It looks small because we have this transformation controller that's actually pushing off a lot of the code there. But we're still doing deserialization. We're doing mesh conversion, and then we're handling the transformation and converting things back, and then converting things again. So there's a lot of different things that happen in this function, and we probably want to make sure that all of those are actually happening. Specifically, we want to make sure that we can convert between mesh clouds and the mesh data. So what we've done, if you're unfamiliar with the sort of design that I've gone with, we've separated our data layer from the internal application models that we're using. And so what that means is that what is inside of what the messages that are coming in are using a separate data model than what our application is processing. And so the advantage of that is if we ever change anything in our in our code that would require new data be added or changed or processed in some way, it doesn't change what we expect to read in. And so we have these two functions here that are intended to kind of translate between the two for us. So we convert into the internal type and then convert from the internal type back to the external type. And that keeps our internal stuff separated from everything else. Big advantage there. You don't run into a lot of issues with updates. Anyway, that's all of that. So let's actually test some of this stuff. The hopefully data stuff isn't too complicated because all we're really doing is just translating between the two using vectors. And so they're just in 2 different formats. The reason we'd want tests here is just to make sure we didn't like accidentally type YX, for example, when we're doing this, because then we'd end up inverting all of our functions. And so this just avoids something like that happening in that translation process. So let's actually do that test. We're going to focus on these 2 functions here. Do we need to do that? The reason I'm hesitating is these are private functions right now. And typically, I'm not a big fan of testing private things because they're internal to the workings of the application and supposed to be hidden. They're intentionally hidden from everything else. What testing your private functions does is it actually forces you to look into the implementation details of every part of your code. And that gets really, that becomes a lot of work. There's a lot of code that ends up in your private functions that is very specific to what it's doing and isn't intended as something for you to directly access. What it creates is a lot of need to work around certain things in order to access that private function. And so it can make your tests really messy, and it can make those tests really unreliable because these private things are going to be changing all the time. A lot of the time, this is where your business logic lies. So maybe what we want is something inside of this to actually handle these. It may be fine for these to be more public because actually translating these would make sense. It also means we've duplicated this function. We can actually abstract that out and remove it from all of this. So maybe that's actually a fine thing to do. Let's grab both of those and delete them and move that into our requests and create a class to handle these. So I'm going to create an internal class. Ooh, maybe internal. We'll work with internal and see what happens. So we do an internal class here called our mesh transformations. I don't know if that's a good name, but we'll go with it, and we can change it later. And make these public. And so this gives us a static class. We'll make this static. That is in charge of handling these transformations for us. So converting between one and the other. This means that in both of our functions, we do not need to do this stuff anymore. We can remove that duplicate code. So this will be our transformations. What do we call it? Our transformation something. Mesh transformations. There we go. So we can replace that in both places. And it simplifies this function. And now this class, this function class, is entirely there for handling the function operation. It's not doing like business logic too much. And I think that'll be more helpful. It also means we can put these two transformations under test without doing public stuff or without testing private code. So hopefully that makes things a little bit nicer. Might seem like I'm making more work by making a private thing public and then doing this. But I think this makes sense as far as access levels go and where this code lives. So kind of refactoring as we go and pulling this into something that handles the data. So all of the data stuff is in the same place and has the same access level. And so let's actually write some tests for that. So we have our mesh transformations. And let's just rename this maybe, so it's something a little bit nicer for us. And we'll call it the mesh transformation test. And so we want two tests here over the mesh transformations object. And these are just going to do this. I'm just copying the signature for a test because I don't know if that's actually easier, but we're going to do it anyway. And so mesh transformation mesh to point cloud. And then we'll do the other test here, mesh transformation point cloud to mesh. Just to validate that these transformations are actually working as we move from one point of data to the other. One of the things these tests are going to provide us is some security that if as people come and try to maintain this code or try to change it, that it still works. Good night or good morning. Happy and fun coding. Thank you so much. It is afternoon for us. I'm in San Francisco. So I don't know where all of you are located, but one way or the other, welcome. Mesh transformation, mesh to point cloud. Let's just do our little outline given when from Spain. Okay, so it's getting quite late there if I remember my time zones. I get mixed up a little bit, but I'm pretty sure that's pretty late. So if you're heading off to bed, good night. If you want to catch this at a time that fits your sleep schedule a little bit better, we do publish these onto YouTube, so you can go and catch these and other sessions on the Microsoft Reactor YouTube and catch up there. So thanks so much for tuning in, and have a great night. All right, so given, when, and expect are sort of our template for writing these tests. So given some mesh, we want to convert it to a point cloud. So we actually already have these meshes. So mesh is just going to come from our shapes, and we're just going to pull in the quad because that's what I have defined. So there's our quad. Then when we transform this, so this will just be our transformed equals our mesh transformations. All right, running into some things, I'm pretty sure there's a way to access internal members from a test. I don't know how off the top of my head though. And I'm not sure if I want to, we're kind of running a little bit behind where I would like to be. So I'm trying to move towards a little bit of that. Unfortunately, just testing takes time. So we might cheat a little bit. The downside of doing this is it becomes a lot harder to undo it later. So there's different, not all technical debt is the same. They can come in different scopes or have different amounts to them. What I'm doing here by making these public actually probably makes sense because it exposes this data type to other things that might want to use it so they can actually serialize in the data type that we're expecting. But making things public is a big technical debt to actually take on, because once something is public, you've declared that other people can see and use that. Maybe it's just other people on your team or other applications in your team, but it could be other applications in your organization or in your company, or even if you're in open source, it could be lots of different companies. And restricting that and removing that is a breaking change for everybody who relies on that. And that's a big thing. That's a lot to handle. And so making that change is maybe a decision that you might want to think a little bit about. In this case, it should be fine because we're publishing things that already are public. These meshes are already public. And what we're doing is making the data layer also public. So kind of aligning the two. But something to keep in mind when making those decisions, certain things can be more expensive than the amount of time it takes to write the code. So it's not a hard code change, but it can have significant ramifications in what you actually expect or what you actually end up hitting later on. That can actually come in and make things really difficult or just hard to change. So something to consider. It should be fine here. So mesh transformations dot something. Actually import that. Formations. I can spell, I swear. Convert mesh to point cloud is what we want. So we're just going to convert our mesh. And then we expect these two things to be the same. This might be a little bit weird, but one thing to keep in mind that we haven't really encountered yet in these tests is you typically want to have one assertion per test. This isn't a hard rule. It's fine if you have multiple. We can do that here. But one of the advantages of tests is that they give you feedback on what is broken in your application. If you have multiple assertions, it can give you this process of figuring out what's wrong rather than giving you all the information at once. So if we do this and then have another assertion here, what's going to end up happening is if this first one fails, that's it. Your test is done. And it will never reach all the logic that is down in this other assertion until you fix the first error. Maybe that's what you want, but a lot of the times we want tests to be targeting a specific thing and giving you a specific answer about whether one specific thing is working or not working. It gives you a little bit more ability to figure out how to actually address some of these issues. And so, good idea. Don't write code that breaks your application. Then you don't need tests. If you can do that, great. I can't. I'm not that good. I don't know anybody who is. So highly recommend just write tests and try to consider how these are going to work. Even if you write really good code, and I'm not saying perfect code, but even if you write code that you think is understandable and easy to use and update and maintain, check in with other people on your team. Make sure that's actually true. Some things that are easy for certain people are hard for others, and vice versa. Like your other teammates may write code in just a different way than you do. And so tests can give a really nice concrete way to figure out how your code is supposed to work. You can also communicate to the rest of the product team or other engineering teams what your application does. You don't always want to try to search through in an application to figure out how that works. If you can find specific tests that define what that application does, it can help you figure out the entire point of that application. Anyway, why I'm bringing this up is we do not have an equality check for these transformations. We don't have anything to validate them. And so we need something to do that. I think there's a few different options we have here. And I don't know what the best option is. We could explore records, which is a new .NET 6 feature in C# 10, which lets you define structs or define reference classes that have data. They're intended for data types, and they give you equality out of the box. We could try that instead of the classes we're currently using. It might also help us reduce our code in general, or we can write multiple assertions and kind of go through that. We'll do both and see what happens. But in this case, we are going to expect a new. Well, this is actually going to be more complicated than I thought as well, because none of these have equality built into them. It's not a thing in this class. If I could find it, there we go. So none of these can compare their equality with anything else. And so what that means is that all of these things would need equals operators added to them in order for us to more easily test these assertions of equality, to make sure that things are actually equal to one another. Let me double check records, because I am aware of them, but I haven't used them thoroughly yet. So it might be something that we bite off more than we can chew. .NET records. I already have them open. Cool. So begin with C# 9. You can use record keyword to define a reference type that provides built-in functionality for encapsulating data. So this is the basic syntax for them. Also could look like this. And it should, hopefully, give us something. I think we can just do this. And then so records structs are added in C#10. And I believe those are used for values, for value equality. Maybe that's what we want to use. Let's give it a shot. If it doesn't work, so one of the cool things with code is if it doesn't work, you can always go back. It doesn't really cost you anything other than your time for these things not to work a lot of the time. So we can actually test this and see what happens. So let's just do a record struct and see what happens. I think this should work, and I think it should give us the thing. The reason I'm a little bit cautious is I don't know how it's going to handle serialization. So we'll see. But I think that should be everything, and then we should be able to just get equality out of the box. We'll see. So let's just run our test. We don't have super thorough tests right now. So this change is more risky than it might otherwise be. But there we go. No overload for equals. That's fine. That test I expect to fail. This needs to be public. And so we expect these transform things to equal one another. So let's do that. Expect new mesh point cloud to have points equal to a new list. Is this how I want to do this? This might not work as well as I had thought. We'll see. I think this might not be as. This might lead to other issues because we might have different list types in our list. But we'll see. It might be fun. So we'll have a vector2 data, and this is just going to do new vector2 data, and we should just get the ability to provide this stuff. So x equals 0 and y equals 0. It'd be a great time to remind everybody, I'm still learning all of this, so we'll figure it out. But I think this should be enough for us to actually get something. I'm using a list constructor here. Again, if you're unfamiliar, list constructors allow you to provide, kind of do an inline constructor for list data. So this is effectively constructing a new list and then running add 4 times to insert each of these new elements in. Let's grab our shapes. And can I just drop this somewhere? Ooh, there. All right, cool. And let's grab our quad quick. So we can just do this. This will be cool because we can just grab this information and plop it in here. Vector2 data. And then these need our x equals and y equals. Cool. And so going to fix this a little bit so these are correct. And then we should be able to just insert our information like this. If I've done this correctly. And if anybody knows more about records, please let me know. Like I said, I'm figuring this out a little bit. So this is our equalities. We're going to do equal to our transformed. So what we're expecting is to convert this quad into this new data format. And this should be zeros. We expect it to be the same thing and equal to one another. So that test should be in here. And it is our mesh2 point cloud test. So we can just run that quickly and hopefully get equality to work or not. This might be something we revert and go somewhere other direction because, well, the good news, they are both using lists. The bad news is we'll revisit this at a later point once I learn more about this. There's good documentation about records. I've still been reading through it and learning it, so we'll undo this for now and come back once I know a little bit more. But for now, I think this will be a safer strategy just to get this working for us right now. Actually, before I undo all of that, be a little bit more thorough, just so I'm not undoing things unnecessarily. Put a breakpoint in, so we can actually test this and validate that things are actually doing what I think they're doing. And so we'll run a debugger here. That should hit our breakpoint with our conversion and let us actually inspect the data that we're pulling in. And so in this case, we get transformed, which is equal to something. X equals 0, y equals 0. So they are the same. They just aren't being treated as equal for some reason. I don't know why. And we have about 4.5 hours to finish this application and get it ready to ship. So overall, like the next 2 streams, which are happening in 2 weeks on the 30th and the 1st of December, we're going to be finishing all this up and getting it ready to ship. So with that in mind, we have to kind of be a little bit cautious about what we're targeting and what we're doing. And this is probably more time than I want to invest right now. So experiment, but we're gonna time box it a little bit and move on. I don't know if time boxing is a common thing, but it's something I picked up at in a different work environment where you give yourself a specific fixed amount of time to tinker with something and then make a decision on that. It may not get you to the perfect strategy or perfect solution, but it gives you the amount of time to explore something without going into down some rabbit hole and never being able to get back out and actually do things. So in this case, we're just going to leave that and write some equal stuff. Public override equals. And this is just going to, if object is a vector2 data, we're just going to implement these really quick here. Vector. This is using pattern matching. If it matches the type, it assigns it to this variable. And so we can now access that as whatever it is. I don't know if that gives us a good signal. If that test fails, I don't know it's broken. So that's why I haven't done that. But that there are different testing options that we could take here. We're not testing everything. That takes a long time, but we are trying to make sure that what we are testing is going to show us that our stuff works. So here we go. We have all of that. What I'm going to do now is some more of this stuff needs to be tested. I will be continuing to add tests over time, but we probably don't need to stream that. This is, I think we've covered a lot of like the different testing patterns that I go through and try to extract tests, like test cases from the code that I'm writing. So hopefully this is enough. If you want more about testing, let me know, and we can definitely, like, I can set up some time to actually specifically look at testing patterns or different ways to write tests and things that are other than a unit test like we've been doing here. We can take a look at some of those. But for now, I'm going to focus on getting all of this to work in GitHub. So actually getting this into a fully working state for us to actually do things with. And then the next time we look at this application, we'll actually be trying to deploy it and manage our infrastructure with it. So writing some GitHub Actions that can deploy our Azure functions, set up our service bus for us, and control other parts of our infrastructure so that the entire thing is sort of contained in our Git. operation. What we've done so far is great. We've set up things so that we can actually go to the portal, create a service bus, and do all of that. The downside with doing that is it's hard to understand the state of your infrastructure if it's done through a portal. It's really hard to figure out what state that's in. And so what we're going to be trying to look at is figuring out a way for us to declare our infrastructure and actually be able to create it that way. So we're not actually constantly revisiting it and trying to figure out what is the current state of our application. It also gives us some nice reproducibility with our infrastructure. So we can actually spin up new instances of this completely by itself without having to go and like copy resources or do anything weird in order to get that to work. It should just happen. So that's coming up. For now, let's add tests for this. So basically, we need to actually run this matrix mesh functions.tests for ourselves. So what that's going to look like, if we go over to Visual Studio Code, we should just be able to run these tests again, just to validate that everything's good. And so I think what we want, if I can .NET test, and then just quickly look at what this supports. What I'm curious about is how to provide a project. So .NET test will provide either a project or a solution to test. So we should just be able to do .NET test. Not even be able to provide the solution, but instead we're going to provide the functions. So what those are named is matrix mesh functions.tests. And this should compile and build our project for us and get us some test results. We do still have those 2 warnings from not having a hash code function. So that will be something that I need to look at as well. But we have 5 passing tests, which should be good enough. And now we can actually do some GitHub stuff. But right now, there is a lot of changes. What's happening here is that we have added a bunch of new projects to this since I've done a check-in, and that includes this test project, which does not have a git ignore in it. So we're actually including the entire project, including all the binary stuff, all the compiled bits, all the object stuff, all of it's in there and being published. We do not want that. So let's remove some of that. So matrix mesh service bus tester. There we go. And we can do .NET new, and I believe it's just git ignore. It's going to create a git ignore file for us, which should ignore all of these obj and bin folders for us. So we don't have as many things getting published. What's in here? We probably also do not want these launch settings to get published as well because they have our environment variable. So something to double check. There should be a way to make this, let me just double check. Well, I don't see it. So we're just going to exclude the properties folder for now, and that should be fine. You could also just not commit it. I find it's a lot better to add it to your git ignore because it prevents you from making the mistake of accidentally adding something to your project. So we can add this somewhere. And this git ignore is intended for .NET projects, so everything that you might want to ignore in a .NET project is included here. Doesn't mean all of this stuff exists in your project. It's just intended as to make it a little bit easier. So let's add our own little thing. Let's just ignore that entire directory. I think it's not a slash there, just so we're clear about what we intend. That should my additions. Sure, we'll use that name. So that's just going to prevent us from pulling in this launch settings here. So we shouldn't get any of our messages in there. We can commit our message. There's nothing secret in there. There's nothing secret in our program because we're actually using that environment variable. And so you just need to provide something. You need to provide an environment variable when you're running this so that it actually knows how to connect to your service bus. But that should cover that project. We do have another one, this matrix mesh function test. So let's go in there and next. Matrix mesh functions tests. We're going to add that other git ignore. That should also remove a bunch of things. So we're down from 200 and something to 19 files, which makes a lot more sense. And then we can also, I think, limit a few other things. One of the things to keep in mind with what's happening in our functions project is there's a local settings.json that was added. This is where I've defined our connection strings and things like that to actually work with this. So that is preventing us from publishing that. By default, it's automatically added to GitHub. There's a git ignore as part of this project template that automatically excludes local settings.json for you. So you shouldn't provide any extra information if you start adding things here. So that's good. It means we're not going to leak any of this. And then our properties, just to double check, should be good. Don't know what that is, so it's ignored anyway, so we're good. Just double checking. And I think everything else is good as well. There's nothing secret in our project definition. So all of this should be good. So I think we're ready to kind of add all of this stuff to Git. So let's create a new branch. You can do this after you've been working on something. So in this case, I've been working directly on main. We can just create a branch. We haven't committed anything. And even if you have, you can still create a branch and then revert your main afterwards, and it should all work. But in this case, we're just going to add Azure Functions as a thing. I automatically added little dashes between each of those because I forgot that we were naming a branch. They can't have spaces. So we get this. Let's actually add these and commit them. So if we look what's actually in here, we have a deletion of class 1 because it was unused. And then the 2 project definitions that we have and everything else. So I think this should be good. Just to double check our service definitions. And so let's add this to our project. We add Azure Function Support. With those 2 things, we can commit this. The other thing that I want to do, this is going to run tests when we create a pull request to pull this into our main branch. But it's not going to run all of our tests. It's just going to run the tests that we've defined here, which are only targeting this project, the matrix mesh math.tests, which isn't any of the new tests that we just wrote for the mesh functions. So we actually need to change this a little bit to actually make this do what we want. And we probably want a few different things to happen here. We can tweak this if we would like. And there's, like all things, there's always different ways to do this. We could provide a matrix here to fork, or I don't know the term for it, but to run 2 concurrent versions of this against different projects. And so what that might look like is, let me actually go and figure out what that would look like. So let's go and grab our matrix, GitHub matrix. Build matrix. All right. Let's do something a little bit less vague. GitHub's matrix strategy. There we go. And so we look at our workflow syntax. What a matrix is going to do is define a set of different parameters to run your action against. And it's going to actually run different jobs targeting each of those concurrently. So each job on whether different machines or different projects, or in this case, different things, it will run in those. Where strategy matrix, cool. Let's go and pull this. So again, there's different ways to do this. I didn't look at where this goes. Same level as steps. So we provide a strategy here. And what that's going to do is provide a way of executing these jobs. So this tests job is what's actually being executed to run the tests of each of these things. So in this case, we want to, example is targeting different versions of Node to make sure your project would run against different versions of Node. That's not what we want. What we want is to target our projects. I guess we can just call it project. And this can be an array. So we can either do it in that array syntax with the square brackets, or we can just add some dashes here. And we'll call this matrix mesh math.tests. And the other one we want to test against is matrix mesh functions.tests. Expected a string. Okay, weird. All right, YAML's weird. White space matters in YAML, and I don't always get that correct. But we're going to add this. Also, quotes and double quotes should be the same. Why doesn't it like this still? Interesting. This should be correct. Not entirely sure what's going on. But well, I think this is fine. If not, GitHub Actions is going to get mad at me and give me an error. So we can fix that if it happens. But what this is going to do is run two versions of this tests job with different parameters. So it's going to run it with our matrix mesh math.tests parameter and with the mesh functions.tests parameter. And this will allow them to run concurrently. This could be useful if you have longer running tests. We only have like 6 tests, and the execution time is like milliseconds. So maybe this doesn't quite make sense. We could just add them here. This would work. We could provide that there, and it would be fine. But doing it this way means that they'll run concurrently, and we can actually get different results from both of them. So if we were running these sequentially, one after the other, one might fail or throw an exception or cause an error and prevent the other ones from running. What I'd like to have happen is for both of my tests to always be run and to get test results for either of them. And then if there's a compiler error, maybe both of them fail. But hopefully that doesn't happen and we get negative or positive results from both. You can do whatever makes sense in your execution, but that should be fine. I don't know why it is giving me errors. I think it's fine. Maybe I'm looking at the wrong thing or did something wrong. But I don't think I've screwed anything up. So I think just my IntelliSense is wrong. We'll find out once I run this. So we get both of these. We need to actually tell this to use that parameter, which I believe is $bracket and then the name of the thing. So we're just gonna grab that sample and plug it in here. This is our project. And then this means as we add new projects to this repo, as we add new test projects or anything that we want to do, we can just add it one line to this project list, and it should automatically restore and test all of them for us. I think that makes the most sense. We'll see. So update test action to validate tests. Might have used test a few times too many. Let's actually add this. Here we go. And commit that. And then I'm going to publish this. So what publish is going to do is push this up to my remote repository, which is out on GitHub. You would not see these changes without hitting publish. So if you go to GitHub and you're like, what's going on? It's not there. You probably need to publish or push your changes. Depending on what environment you're in, it's push from the CLI or publish from Visual Studio Code. You could also do that from Visual Studio's Git Explorer here. You can just change what's going on here and do the same thing I just did in Visual Studio Code, but in Visual Studio. They both work. So let's actually look at what we did. So if we go github.com and grab our matrix, we should have our new thing here. And what we can do is just open this pull request. We changed the pull request GitHub action, which means that when we open this pull request, our new changes are going to be run to test this. So if we create a pull request like this, add Azure Functions, we'll see we have 2 commits here that were just created for us, and 2 checks are going to be run. So we only have 1 GitHub action defined, but 2 of them are showing because we're actually running against both different things. You can see the 2 different options, the 2 different parameters that we provided to our matrix being shown here. And this will actually give us 2 greens or 2 failed checks or one of the other. So I find this a nice way to see this information. We can actually go into details and look at what's happening here. We'll see both jobs be listed. So we have a little bit more information about what's actually happening in our code. But this should give us 2 greens and we should just be done as far as this is concerned. There is one more thing that I want to add here. One of the things that's happening with this pull request that I like to validate is your pull requests are going to be run when a change happens to that pull request. What that means is if 2 pull requests are both opened, and then both of them can be merged together into the main project and there's no merge conflicts, GitHub will just let you do that, which is fine. The downside is that might actually break your project. Just because you get greens here, it only means that it passed in this state, which with whatever state this is in. It doesn't mean that everything is going to pass. I could open another branch and create some other changes and check those in before this. And then when this is merged, that could break. So one of the things that I like to do is actually validate that the main branch is in a green state. What that means is that tests pass for the current version of main, as well as for the pull requests opened against it. And so what that would look like is pretty much the same thing we just did. But we're just going to add to this pull request and make it do what we want. So we're going to copy this and create a new workflow file. So on push to main.yaml, we're going to run through and do some more tests. So this is going to be on push to the main branch. Validate state of main branch. Validate main. Sure, names are hard. So this, instead of doing pull request as our trigger, we're using push. So push means things are pushed to that change. So anytime any code is pushed to main, this will run again. And so we should just be able to run mostly the same stuff. I don't think there's actually any changes required for this. All it's doing is rerunning those tests after changes have been pulled in. And then what we can do is actually append additional actions here that maybe do something else, like deploy, for example. Just as a quick example of like things that we could do. And this could needs test, I believe is the name we use, tests. So this is just a really quick example. We're not going to complete this right now. That's probably going to happen next time we stream this. But what this is doing is giving us a way to validate that the current state is correct and allow us to act on that rather than just hoping that things all work after they get merged in. So that's what's going on here. We could probably also add some actions to maybe revert changes if they did not work. It depends on what makes sense in your project. For me, I don't know what the best solution is. So we'll discuss that when we get to it next time. But for now, this should be enough for us to actually have a test job on pull request, or on push, rather. So what we're going to do is push this. So this is going to be run tests on pushes to main. And I need to remember to actually add the files to my changes. You don't need to add all of the files in your change. So that's why you get an error there. You can just add 1 or 2 files out of the 50 different file changes you have. That might make sense, might not. In this case, it should be good. So we check that in. What we should see, I already synchronized this, so it should already have been pushed up. We should see more actions being run. So if we actually look at this, we have 2 more actions being run because a change was detected in that pull request. Now, and so we have both of these running. We should eventually get a green light to actually merge this in. And then from there, we can actually do some work. I believe I'm an admin, so I can just override these checks. But you may not necessarily have that option, especially if you're committing to some project outside of whatever you're working on directly. Different things will allow you to do different things. In this case, we're going to pull this in, and we should see our test run a 3rd time, just to validate that the new state of our code is fine. To double check, or just to kind of prove, I guess, what's going on here. Is this a good idea? No, we'll leave that for later. I think I already hammered in on this topic a little bit too much. So we're going to squash and merge this into the main branch and get some changes. There's 3 commits in this change, so each of them are listed here. I'm using squash and merge, which means all of these on the main branch are going to appear as a single commit. So this is, instead of having these 3 separate commits doing 3 distinct things, we're only going to end up with the one. Which can help kind of isolate things down to pull requests, so you know when things are merged in, and you can actually go back and look at the history. The pull request number is in your commit. Add Azure function support, update test action to validate tests, and run tests on push to main. And that should be good to actually merge in. We get our changes merged, and we can delete the branch. And so deleting the branch is largely just for cleaning up, so you don't end up with a bunch of stale branches that are just like worker branches. And so we go and look at what's actually happening now. You can see there's this little yellow circle here. That indicates that something is running. In this case, we have the 2 checks that are now triggered running our actions to validate the push that happened. So we have 2 workflows now defined rather than the one we had previously. We had our validate pull request to actually validate the pull requests we're working, but then we also have validate main, which is running for the first time right now. And so what that's doing is actually validating our current state is fine. You can see which branch they're running on. This is running on the state of main. And so this will be useful if we're trying to talk about automatic deployments or synchronizing this some other way to actually send information to production in some way or interact with anything really. We're probably going to be looking at automatically deploying these Azure functions. We want to do that after our tests have passed, not just hope everything's good. So that's where this is kind of all leading,
is we have tests now that we can run on our push that prove that everything is good. And then after all of that, we can require these tests to pass and then run our functions and deploy those into our cluster to actually start running them. So yeah, I think that's largely where we're going. Hopefully this was helpful. We're kind of working our way towards finishing this app. We have 2 more days of streams left, both of them 2 hours. They're coming in 2 weeks' time. We're taking a little bit of a break for some of the holidays here. But other than that, we should be good. If there's other questions or ideas or suggestions you have of things we should look into or test, we do only have a limited amount of time, but we can extend this project with additional series later to kind of take a look at that. This was targeted as a MVP, as something to kind of quickly approve a concept. And then we can go back and address a lot of the technical debt, or maybe some of the decisions that were done in the interest of expediency and getting things done, rather than the interest of long-term architectural goodness, whatever the term for that is. So there's definitely compromises that are sort of embedded into this application and things that we can go back and fix. There's also 2 ends on either side that are going to be producing and consuming from these queues that we've created that are going to be working on that. So that's sort of where we're going next. But other than that, I think that's pretty much everything. So I think we're mostly finished. So thanks everybody for watching, and I will see you all when we pick that back up.
Thank you, Sam, and thank you, everyone. As Sam mentioned, we will be off next week, and then we will be starting again on November 30th with the last 2 parts of this series. I've shared the link to the series page a couple times in the chat, but I will share it again. If you want to check out any of the past sessions, look at those recordings, or register for the upcoming sessions, you can do that on the series page. And we hope to see you then. Thank you again, Sam. Talk soon. Bye, everyone.